All right, so starting with number 1, the jewelry box. It says Elaine's rectangular prism jewelry box has a volume of 36 centimeters cubed. Which of the following could be the dimensions of her jewelry box? Select all that apply and explain why. So we're given the dimensions in each case, and we just have to verify to see if which one has a volume of 36 centimeters cubed. So starting with A, we're going to do 4 times 4 times 2. Since they're rectangular prisms, we just multiply the 3 numbers. So 4 times 4, I'm not going to show the calculator in this video, but 4 times 4 is 16. 16 times 2 is 32 centimeters cubed. So that does not have a volume of 36 centimeters cubed. The second one, volume, is going to be 3 times 2.5 times 4.8. But when we multiply those, we actually get 36 centimeters cubed. So that one works. The next one, 12 times 12 times 12. So we do have to be careful because in this case, if we were to add 12, 12, and 12, we would have the correct volume. But in this case, since we're multiplying 12 times 12 times 12, that volume is going to be too large. That's going to be 1,728 centimeters cubed. And then lastly, 3 times 4 times 3. 3 times 4 is 12. 12 times 3 is 36. So that has a volume of 36 centimeters cubed as well. All right, now looking at number 2. So it says you work for a company that designs gym bags. The newest line of gym bags must have a total volume of 150 centimeters cubed. Design 2 different size gym bags that fit the requirements for volume. Sketch a picture of both gym bags to verify they meet the volume requirements. All right, so doesn't say in this problem, but we are going to be dealing with rectangular prism gym bags, kind of like those Adidas gym bags that we see. And we're going to do 2 with different sizes, but they must both have a volume of 150 centimeters cubed. Or, yeah, centimeters cubed. So I think the easiest way to do this, we know that for volume, we do length times width times height. And we know that our volume has to be 150. So essentially, we're just looking for 3 numbers that multiply to make 150. So what I think of is 2 numbers that multiply to make 15 might be 3 times 5. And that would get us to 15. To multiply, to get to 150, we would have to multiply that by 10. So 3 times 5 times 10 would give us a volume of 150 centimeters cubed. So 3 and 5 and 10. And now looking at the second one, so we basically have to do the same thing. We need 3 numbers that multiply to make 150. Well, if we think we can multiply 2 times 7.5, that would get us to 150 or 15. And then in order to get to 150, we know that we just have to multiply that by 10. So 2 times 7.5 times 10 would give us a volume of 150 centimeters cubed as well. All right, now looking at this next one. So it says the volume of a square pyramid is 432 inches squared. The height is 9 inches. What is the length of one side of the base? So we're dealing with a square pyramid. And we know that a square pyramid has a square base. And we know the length and the width are the same. And we don't know what those are. But we do know that the height is 9 inches. So this is a working backwards problem, and I know that because we're starting with the volume and we're asked to find one of the sides. So I'm going to start by writing out the formula for the volume of a pyramid, which is length times width times height divided by 3. And since we know the volume, I'm actually instead going to write 432 here. All right, so a couple ways we can do it. What I'm going to do is I'm going to simplify this. Since 9 divided by 3 is just 3, I'm just going to simplify that. This is going to be 3x squared. And then from here, we're going to divide both sides by 3. So 432 divided by 3, we get 144. And then lastly, to get x by itself, we need to take the square root. So we get 12 inches. So each side of the base is 12 inches, and you can verify that this is correct by doing 12 times 12 times 9 divided by 3. And if you put that in your calculator, you should get 432. So you can double check your answer by plugging it back in. All right, so looking at this second one here, the melting pot, so it says you have 50 metal spheres with a radii of 4 meters, and they're melted and then poured into a rectangular prism box with base dimensions 2 by 6. We want to find the height of rectangular prism. All right, so let's first start with the volume of the sphere, which is going to be 4 times pi times my radius cubed divided by 3. So in terms of pi, we get 85.33 pi, but I'm going to use the approximate answer since my other shape does not involve pi. So we're going to take that answer and multiply it by pi. So we get 268.08 meters cubed. And that's one sphere. But since we have 50, I'm going to take 268.08 and multiply that by 50 to get the total volume, which we get 13,404.13. So this represents the volume of all 50 spheres. Okay, well, since we're taking that mixture and melting it and turning it into a rectangular prism, we know our rectangular prism has a base 2 by 6, and we need to figure out what is the height. Okay, so we know to find the volume of a rectangular prism, we do length times width times height. And we know that these volumes have to be equal. So it's going to be 13,404.13 equals 2 times 6 times h. So this is 12. So we're going to divide both sides by 12, and that's going to give us our answer. So when we divide that answer by 12, we get 1,117.01, and our units in this case are meters. All right, next problem, the ice cream cone. So it says a spherical scoop of ice cream has a radius of 3 centimeters. So we're going to start with a spherical scoop of ice cream. And that ice cream, like I said, has a radius of 3 centimeters. And it's going to sit in a cone with the same radius. We want to know, what does the height of the cone have to be in order to hold all the melted ice cream? So basically, if this ice cream were to melt and fit perfectly in the cone, what would the height have to be? So we know that these two volumes have to be equal. Okay, so first thing I'm going to do is I'm going to find the volume of the sphere, which is going to be 4 times pi times my radius cubed divided by 3. So if we wanted, we can keep these both in terms of pi just because both shapes involve pi in some way. Since they both involve circles, so that's going to be 36 pi centimeters cubed. And we know that the volume of this is also going to have to be 36 pi centimeters cubed for it to fit in perfectly. So the volume of a cone we know is pi times the radius squared times the height divided by 3. So filling in this volume here, so it's going to be 36 pi equals pi. We know the radius is 3 times the height divided by 3. Well, since we have pi on both sides, we know that we can divide by pi. They basically cancel out. So then what we're left with is 36 equals 3 squared is 9. And then we can divide here. 9 divided by 3 is 3. Oops. This is going to be... Oops, I don't know what happened there. Why I can't erase that. There we go. So this is going to be 3h. And then last thing, divide both sides by 3. So the height of the cone is going to have to be 12, and our units are going to be centimeters. All right, now dealing with this last one, a little tricky, but it says that we have a tennis ball can in the shape of a right cylinder, and it holds 3 balls snugly. Okay, so here's my can. And there's 3 tennis balls. Okay, all we know is that the radius of the tennis ball is 3.5. Okay, I want to know what percentage of the can is occupied by air. Okay, so essentially what we're trying to do is we need to figure out what percentage of the can is the empty space. Okay, so we know we're dealing with a composite figure since we have both a sphere as well as a cylinder. So let's first maybe do the easy thing. Let's find the volume of our spheres. Okay, so the volume of the balls we know is going to be 4 times pi times my radius cubed divided by 3. And again, this is one of those shapes when both of them involve pi, you can just keep it in terms of pi. So that's going to be 57.17 pi. And since we have 3 of them, we're going to multiply that by 3. So the total volume that the tennis balls take up is going to be 171.5 pi, and my units in this case are centimeters cubed. Okay, now we're going to find the volume of the can. So this is a little tricky because it doesn't really look like we're given anything in terms of the dimensions of the can. However, I know that the radius of the can has to be 3.5 since we know the tennis balls fit snugly. What it looks like is, it looks like we're missing the height. But here's what we need to remember. We know the radius of a tennis ball is 3.5, which means the diameter is 7. So each tennis ball has a diameter of 7, which means our total height is going to be 21 centimeters. So we actually do have the height. It's going to be 21. So this is going to give us the volume of the can. So 3.5 squared times 21 is going to be 257.25 pi. My units are centimeters cubed. Okay, so in order to figure out what space is occupied by air, we need to figure out how much air is in the can. And to do that, we need to subtract these. So we're going to do 257.25 pi minus 171.5 pi minus 171.5. So that's 85.75 pi. That's how much air is in the can. And to figure out the percentage of the can occupied by air, we're going to take the total amount of air, which is 85.75, divided by the total volume of the can. So 257.25. Well, we know the pi's are just going to cancel out. So really it's just a matter of doing the 85.75 divided by the 257.25. And when you do that, you get exactly 0.33333, which is about 33%. So the percentage of the can occupied by air is 33%.